Hi everyone. We are going to spend a little bit of time today talking about what we want to call measures of central tendency. This is another tool for us when we work with data and some analysis of that. You can think to some of the other things we've done with data, like our histograms and our different types of graphs that we've done, bar graphs, stem and leaf plots, things like that. When we talk about measures of central tendency, we're really talking about ways to find central values of sets of data. Sometimes when we talk about that word central value, we can also describe that as being typical, maybe the word average or the middle of our data. Now, there are three types of measures of central tendency that we are most often going to use. The first is called mean, and you've probably heard that before. The second is called median, and the final is called mode. And you probably have worked with these before, but we're going to talk about each three individually today. We're going to talk about what they mean and how to find them. And then at the end, we're going to talk about when to use which type of measure of central tendency, which is an important part of this process. So, let's talk first about mean. This is probably the most common one that you're going to come across when we talk about these measures of central tendency. And this is most likely described as average. And you might hear things like, what's the average height of people, or what's a batting average of somebody? Well, in order to find average, we are simply going to find the sum of all of the numbers in the data set. So if we're talking about heights, we find everyone's heights. And then we're going to divide that by the amount of numbers in that data set. So if I added up 15 different people and their heights, I would then divide by 15 to figure out what the average height would be. So let's do one quick example of this today. We're going to talk about a short and simple example that we're going to use for several of these. We'll say the average age of 6th graders. Now, if we were in class, we could do a full class of people, but just for time and example's sake, we could take a look at some measurements like this. Maybe we have students that are 11 years old and 12 years old and 10 years old in our class, and so we would simply want to add all of those numbers up together. So here's a small sampling of 6th grade students that we've added together. Next, we remember that we are going to divide by the total number of data points in that set. So I would just count up all the numbers that I added together and see that there were 9 data points there. Now, as I do that, I'm going to remind myself of some order of operations rules. Remember, fractions are really one big number, so we have to figure out what the top value of that number is, even though this particular fraction looks a little funny. So I've added up all those numbers, and I see that that's equal to 99. Then I'm going to just divide that by those 9 numbers in the data set, and I would determine that 11 years old was the average age of 6th graders. Now, in this particular list, you probably could have looked and you probably could have seen that without even doing any of this math. This becomes more helpful the more numbers that you have in your data set. Now, let's talk about median. The definition of median is the exact numerical middle of a set of data. You may have heard the word median before if you are talking about driving down the road. Sometimes really big streets have a median in the middle, and that's sometimes made of concrete, or sometimes it's just that wide lane with double yellow lines where cars are not supposed to drive that separates traffic. Well, that's almost always on a road exactly in the middle of that road. And that's the same thing with median when we're talking about numbers. It's the exact numerical middle of a set of data. So, it's pretty easy to find that. Again, all you need to do is create an ordered list of your data. Once you've created that ordered list of your data, count to the middle. And there's lots of different ways that you could count to the middle. I'll show you one quickly today. One other quick tip here is an ordered list is actually always helpful for us. Even though you don't need it in mean, because we end up using different sets of measures of central tendency, often the first thing that I'm going to suggest that you do is order your lists from smallest to largest, and that'll make it really easy. So I'm going to take the exact same set of data that we had before in the same example. So we're going to talk about the average age of 6th grade students. In this case, we're talking about typical age, or maybe the middle age. So here was my original list that I had. I had all of those parts, and then what I wanted to do was I wanted to put these in order. So I'm going to start putting these in order, and as I put them in order, I'm going to cross them off. By crossing them off, I'm going to make sure that I haven't forgotten any sets of numbers that are there. And I'm also separating my numbers by commas, hopefully helping to make sure that I don't accidentally think that I have a bigger number in this set of data than I actually have. Next, once my numbers are all in order, I'm going to simply start figuring out what the middle is. So the simplest way for me to do this is I'm just going to cross out on each side until I end up at the middle. I crossed out 4 on the left side, and I crossed out 4 on the right side. That's a great way for me to check to make sure, hey, I did this correctly. I ended up in the exact middle of these numbers. Now, our next point that we want to know about median, because there's one special thing that can happen, is what we saw was an example that had an odd number of data in our data set. In fact, we had 9, if you remember that before. But things look a little bit different if we have an even number in our set of data. Now, in this case, I've simply added another 12 at the end of this, so that now I have 10 pieces of data in this data set. You're going to see when I go to cross out my numbers that I end up with a problem. I have 2 numbers in the middle instead of just 1. So if you ever end up with that situation, all you need to do is find the mean of those 2 numbers. In this case, 11 plus 11 was equal to 22, and divided by 2 was still equal to 11. However, oftentimes those numbers that meet in the middle might not be the same number, and so you may end up with something that looks a little bit different there. Finally, we're going to talk about mode. And mode is the data that occurs the most often in our data set. So again, I'm going to take a look at the same example that we've been using. And I don't even really need you to have a definition of how to find the mode, because it's pretty easy. You're simply counting. I counted my 10s. There were 2 10s. I counted my 11s. There were 5 11s. I wrote 4 down there, but that should say 5. And there were, if I go to my next spot, there were 2 12s. So with that information, I know that 11 was the mode. That's pretty simple. Now, in this case, we want to talk about which measure to use. We're going to talk about mean when the data is evenly spread out. If our data is pretty evenly spread out, or we want to count all of our data the same, we're going to use mean. This might be something like your grade point average. All of your classes count the same amount, so we would use mean for that. Or in the example of the ages, all of our ages were pretty close together. We're going to adjust things, though, just a tiny bit here. What if instead of asking the average age of 6th grade students, maybe I asked the average age of people that were associated with a hockey team? And you can see that I have the same list here, except for I've included the coach, and the coach is 58 years old. If I used mean and followed my same process, I would add all those things up. I would divide by my number of data sets. Well, that got me 145 divided by 9, which meant that my average age was 16. Even though mathematically that's correct, that doesn't make a whole lot of sense. And so this is an example when our data is skewed, we want to use the mean. When our data is skewed, we want to use the median. And so here we see this same example when our data is skewed, and now we're going to use the median. I'm going to follow my same steps. I'm going to cross out, and we're going to see that 11, and that seems to work a lot better. So if our data is skewed or if there's extremes in our data, we're going to tend to use the median. If our data is pretty evenly spread out, we're going to tend to use the mean. Finally, we are going to, excuse that there. Finally, we're going to talk about mode. And our mode is usually going to be when data isn't numerical or numbers. Or you're also going to use this if you have lots of repeating values that occur. Okay, so if I asked favorite flavors of ice cream, we would probably describe this with mode. Or if I happen to see a set of data like the ages of 6th grade students that had a lot of 11s in it, then sometimes that's going to work. But we still want to make sure that those repeating values aren't skewing our data. So if our data is skewed, if all of those numbers happened on one side of our data, maybe I had a bunch of 2s in that data. That still wouldn't represent things very well in that particular instance. I hope this gives you a little bit of an idea of how to work with mean, median, and mode. Good luck.